Today we looked at solving word problems using algebraic equations, and when we do that we want to think about how we could model it. Could we model it with a picture? We want to define our variables to very clearly communicate what our variable is representing. We're going to write our equation, solve it algebraically, and then answer the question. So for the first problem, the width of a rectangle is 3 less than twice the width. The perimeter is 24 centimeters, and we want to find the length and the width. So we can draw a picture of a rectangle, and we have our length and our width. And in this problem, it says the width of the rectangle is 3 less than twice the width. So they're telling me something about the width of the rectangle. What I don't know anything about the length, so I am going to let the length be L. I'm using a capital L just so my lowercase l's don't look like ones. So then we need to think about our picture. We would have, it doesn't really matter which one you call the length and the width, but we would have two sides that would be equal to L. And then we know for the width is 3 less than twice the length. So for twice the length, we could write that as 2L, right? We're taking L and multiplying it by 2, doubling it. We don't want just twice the length though, we want 3 less than that. So we're going to take twice the length, and then we need to take 3 away or subtract 3. So I would have two sides that would be 2L minus 3. And then the other piece of information that we're given, we know the perimeter is 24, so then we have to think about what the perimeter is. Remember, perimeter is the distance around that shape. So if I were going to find the distance around, one side is 2L minus 3, plus my second side is L, plus my third side is 2L minus 3, plus my last side is L, and when I add up all 4 of those sides, it is equal to 24 centimeters. And then once we have our equation set up, we know how to solve these equations. We're going to combine like terms. So I have 2L plus L, it's 3L plus 2L plus L. That gives me a total of 6L. And then I have a minus 3 and a minus 3, so that is minus 6. If we're going to solve, we're going to add 6 to both sides. So 6L equals 30. Divide by 6, and L equals 5. We're not finished. Find the length and the width, so we just figured out that L is 5. We need to find our width. We know our width is 2L minus 3, so that would be 2 times 5 minus 3, which would be 10 minus 3, which would be 7. And we always want to make sure that we're communicating what we found to make sure that we're showing complete understanding of what those numbers mean. So we're going to answer that question. So the length of the rectangle is, and the length we found was 5. Remember, that's 5 centimeters. So the length of the rectangle is 5 centimeters, and the width is 7 centimeters. For example 2, twice the sum of a number and 3 is the same as the difference of 4 times the same number and 19. Find the number. So if we're thinking about what we don't know here, we don't know what the number is. So when we define our variables, we're going to very clearly say that x is equal to the number. And then it's a matter of translating those words. So the first piece that we can look at, sum is adding, remember. So it says the sum of a number and 3. So if we're going to add the number and 3, remember that would be x plus 3. But we just don't want the sum of a number and 3. We want twice that. So we need to multiply that x plus 3 times 2. So to show that, we need to make sure we use parentheses around the x plus 3. So what we have so far is twice that sum of x, of that number and 3, is the same as, there's our equals, And then we have the difference of, remember difference means subtract. So we know we're going to be subtracting something. It's the difference of 4 times the same number. That would be 4x and 19. When we're reading something like the difference of or the quotient of, that gives us the order of that operation. So the difference of 4 times the same number and 19, the difference of 4x and 19 is 4x minus 19. Then we would use our equation solving skills. We would distribute, we would finish solving that equation, and we would answer that with something like the number is, just as simple as that for that sentence. If we look at example 3, 130 students went on a field trip, 4 buses, same size, same number of students were filled, and 10 students traveled in cars. How many students were on each bus? For this, we might not necessarily have a picture like we did with the rectangle, but we could pull on our knowledge from elementary school and 6th grade to use a tape diagram. So we know we have 4 buses, and we know we have 10 extra students that are in cars, and we know that there is a total of 130 students. What we don't know yet is how many students were on each bus. So when we define our variable, I'm going to use the letter B. B is the number of students on each bus. We don't want to say students or bus because it doesn't really clearly explain. We want to be explicit. So the number of students on each bus. So on this bus, there's B students, B. And when we're looking to write an equation, if we know a total, sometimes it's helpful for us to write an equation that equals that total. So I'm going to add up all of my students on the buses. If I add the bus students and the car students, that should give me a total of 130. If I look at my tape diagram, we have 4 B's here. And then we have this extra 10. So when we write our equation, we could write 4B plus 10 to get that total of 130. And then again, we could solve that equation using our skills and give a sentence that says there were blank students on each bus once we have that solution. Then for number 4, the sum of 3 consecutive numbers is 162. Let's find the numbers. So if we're looking at consecutive numbers, consecutive back to back, so it would be great if the Braves won consecutive World Series championships this year and next year. So consecutive numbers like 3, 4, 5, 10, 11, 12, 29, 30, 31. And those are just a few sets of 3 consecutive numbers. Notice from like 3 to 4 to 5, from 3 to 4 we were adding 1. From 4 to 5 we would be adding another 1. So when you see problems like this, to define your variables, we can make it as simple as the first number, the second number, and the third number. And it's easiest to make that first number x. So then for the second number, remember going from 3 to 4, we added 1. We're going to use that same thought process. So if my first number is x, my second number would be x plus 1. Then my third number, we would have to add another 1, and we would get x plus 2. And it says the sum of those numbers, remember sum is our keyword that we're adding. So we're going to add those 3 numbers, and our sum is 162. So then if we add them, the first number is x, the second number is x plus 1, the third number is x plus 2, and then we could combine like terms. So 3x plus 3 is 162. So we could continue to solve, subtract 3 from both sides, we get 3x equals 159. Divide both sides by 3, we get x equals 53. So we know that this first value is 53. And then if we add 1, we would get 54. If we added 2, we would get 55. And then we would create our sentence to show that we understand what we found. So the 3 numbers are 53, 54, and 55.